I mean, again, I'll say what I said, some of you may not have been here, in the previous little grouping of talks. This grouping, when you're organizing a session, we're very lucky we got the number sufficient, we got, over 20. And so I had to find a way to organize them, right? So this was a bit of a shot in the dark because they didn't have their slides, I didn't have their slides, I kind of had to guess a little bit. But I think we did well, and I was hoping that this grouping would talk to us, as I said at the beginning, a little bit about math, a little bit from the outside. What I meant to say is also how math is used, what difference does it make? The previous grouping was more from teaching math, how we teach math. But sort of why do we care about math and how is it used from the outside? And I think you've shed light sort of from physics, obviously, AI. I mean, Jeremy, listening to you, I felt like, yeah, we might actually, I didn't come in believing that, but I almost was convinced that they were going to be out of the job. And then I was like, well, what job was that I'm going to be out of anyway? And Spencer, of course, this notion of monad, and I love that you stuck with, that's such a great little nugget. My students love it when they get, and it's the kind of thing when they get it, they're like, oh yeah, they're everywhere. These monads are everywhere. But then they don't have the words. All you can do is bring examples and say, it is what is common amongst all these examples. That's what they want to say. So, but I wonder, thank you, there's several of you. Please, any questions or comments?
In your experience, how do you think AI can be an effective tool for posing questions for research?
That's a good question. So I do like to emphasize, I grew up in the symbolic trade. I like to distinguish between good old-fashioned AI, the symbolic tradition, and neural machine learning AI. I characterize them as being complementary. Symbolic AI is very rule-based, very precise. You know exactly what it's doing, but in any search, it just gets lost. Machine learning is that you can synthesize lots of data, it detects patterns, but you don't know what it means. And so I think the two are best used in conjunction. But machine learning is, as we know, it's good for synthesizing lots of data and come up with things that are approximately right. And very often that's helpful. So people will report that, if you ask, one of the big frontier models to prove a theorem, right now they've gotten to the point, well, they'll give you answers that are wrong, but helpful. Right? They've seen the whole literature, and they'll say something. And what they say is just wrong, but it'll point out connections or make suggestions, and it'll help things along.
Can I add something to that?
Yeah.
I wonder, I'll say it as I wonder, I know a little about it, but I'm sure you know more. You said it's helpful, and we often say mistakes are very helpful. We actually mean it, that later on in the session we'll have more examples of that. But I'm really excited about you bringing this up. Where does that assessment of it being helpful reside? Does it reside in AI? Does it reside in the thing that AI said? Or does it reside in the human listening to what the AI said? So would another AI listen to that and, would it be useful for that other AI or not?
I think the answer is all of the above. But certainly, I'd like to emphasize that when we talk about AI for mathematics, it's really, we care about what it's going to do for us, right? So, particularly, so Albert Jang is a young researcher now at Mistral. In his dissertation, one of the papers, they actually, with Tim Gowers, with some subjects, they actually did experiments where they had these controllers where they asked mathematicians assessment. But I was talking more anecdotally. But I think it's it's typically people anecdotally reporting. Yeah, I asked ChatGPT. I was trying to prove this theorem. I asked this question. The answer was nonsense, but it helped me find the right solution.
The reason I'm asking is because there's this idea. I think where AI has gotten to right now is, for me, it is a great point because of what it's not telling us, or because it's opening up, it's having us question some things that we never were questioning before. In particular, the difference between what we say and what we mean. So that if the meaning resides in the human, let's say, and the meaning that the human has, or the access that the human has to some notion of meaning, which is vague, doesn't match what we're seeing or what they intuit as the meaning in what AI says, that disconnect is generative in some ways, but that is not in the AI. But the AI is an indispensable input of sorts, right?
I agree, and I think of that as a more positive use of AI, where we're interactive.
I have another question for Jay. So you mentioned how the industries, the tech industries' motivations or values are not aligned with the values of research organization. And Michael Harris talks about this in this article with last 2 or 3 years ago. The title was Automation Controls Manufacturing to Reflect on Our Values. And at that time, I was really influenced by that. I was thinking just we should be having seminars and discussions in all our back departments about this. What are our values? Because we don't really have a collective sense of our values. Each of us individually has some mathematical values that we care about, but I don't think there is a list of values that mathematicians will say this is our list of values. So shouldn't there be more of a push for math departments to collectively reflect on that?
There should be more discussion. I mean, the reason I do talk like this is I want them to continue talking about these issues. They should be discussed. I mean, so Michael Harris has become a very good friend. I mean, he's been very critical of me sometimes, but also very, very positive about me. He goes both ways. I think, we worry about some of the things. I mean, Michael is much more skeptical and much more, as you know, much more skeptical, much more critical of big tech. And again, I think we need to be careful, but I'm less, I'm less swayed by his core concerns. But actually, there's a lovely meeting in Leiden a few months ago that was designed to start talking about these issues. And I think Michael is involved. I mean, there was a team that trying to come up with guidelines for mathematicians and manifestos. I think Michael may be talking about this. We need more discussion in the mathematics community. I mean, I raise these questions because I don't know the answers, and it's not. I mean, it's for all of us to answer collectively. So I think Michael is doing a very good job of raising concerns and worrying and prompting people to think about them. But we all need to be.
I think we need more opportunities to do that also, because administratively, math departments are still stuck in their own job of teaching the courses and then but they are not finding the time and space to that they need to create to start having these discussions that are important. So I think we need more opportunities for the math departments to do so. I'm not sure how to do it.
I think foregrounding the question why we do what we choose to offload, let's say, to an AI. I mean, Spencer, you ended on that thought, on that point of sort of the stepping back, the difference between the doing and the why we choose to do versus understand and where the right balance is. And I think honestly, Gabriel, I mean, you kind of asked fundamentally similar questions about physics, like why do physics in physics use a particular formulation as opposed to another? Which is foregrounded? Is the understanding, is the meaning sort of what's driving it, or is the formalism driving it? And you can overshoot one or the other, right? But at some level, we're asking to sort of lift above that, right? And sort of ask the question and do a little bit of both, perhaps. And maybe this is what we need to afford ourselves, is the space and time, kind of like this, but much more ubiquitously, and to honor it, right? To do this sort of thing, rather than simply just do the math, but do the thinking about why you do the math, and what math you're going to do versus, and partly, I think this is my conception of what compassion in mathematics means, because, my collaborators, I said this many times, but I try to consume, at least in the context of this session, compassion as with passion. In other words, where we're looking at the passions that clearly drive us to choose different things. Mathematics is many things, but it's not one thing. In other words, it's bigger than all of us. So why do we choose to say this about mathematics, to ask these questions rather than others? Why do we choose to accept these as answers? Right? So I mean, that's it's a common thread in what you're all saying. If we blindly just accept AI, it's like focusing just on the answers. As you said so well, Jeremy, it's like we might have a future where We just ask questions, we accept the answers in a oracular fashion, right? And that's it. That's what math is. There's no understanding. There's no fun. You know, the big theme from the previous group of talks was about fun. Where's the fun? Why do we do math? You know. So, yeah, I think we need to afford ourselves more space and time and value that we are having fun. There's a reason why we do these things. I mean, what do physicists think?
Well, me particularly, I need to do mathematical models, right? So I need some math that represents the thing that I need to represent. And right now, my job is to figure out what are the correct structures. So if I have something, right, that I can just put a conjecture, say, suppose that I have this, is this true, or can you find a better example? I would be able to be a lot more productive, because it's again the search that I need to do. And so every time for me, trying to find things in math textbooks, and then I find that there is a mathematician who goes, oh yeah, it's all there, and it's never there. So yeah, to me that's my problem, because I need to sort of think at the higher level. And so that are we at the level where I can just have something that says, oh yeah, given this definition, is this true?
We're not there yet, but things are happening fast.
So I just have to be patient.
Well, no, I said, don't wait. Start playing with the technology, figure out what you can do.
So I started playing with ChatGPT, and it's just like it says so much nonsense, and then like to me it becomes more of a problem, because I'm asking about things that I basically don't know, right? Because I'm not in competition. So if I can't rely on the thing that tells me the answers, it's worse than not knowing.
But every iteration of the models, they keep getting better. I mean, so again, a couple of years ago, in any question you ask, not a question, you get told nonsense.
Yeah.
But no longer. They're getting better.
Life is not experience. Like even simple things on topology now, use the closure of this or that, open set. Oh yeah. And then I tell you over the internet how to do that.
And you say, are you sure? He says, no, wait a minute. No,
That's the trick. I have to
yeah.
I have a question for Mr. Carcassi. So, in some sense, you know, classical mechanics would be considered an approximation of quantum mechanics. But you discussed trying to find some ideal objects to map onto the mathematical world. Well, if classical mechanics is an approximation, then is it an approximation like less ideal? What is the criteria?
So this is something that I strongly object to. So all physical theories are approximation. So there's no point of saying that one is more approximation than another. And it's verified in a specific realm of applicability. You have a system, it satisfies some conditions, therefore you can describe it as a certain way. That's the correct way to think of it. And then you say any physical system will have some basic conditions. It needs to be experimentally accessible. I need to have preparation procedure. And so those things form sort of let's say that the set theory or whatever, the more fundamental view. I think it's a big mistake in physics that people think of finding the one true theory of everything. No, it's like in mathematics, you don't try to find the theorem of everything, the theorem that proves out things. So what I'm trying to do is structure the foundation of physics more like the foundation of mathematics, where you have different models, and then you pick the model depending on what is each.
And you know, we had the crisis, which some of foundations, and some people think they're still going on, so, or at least we're reopening it. So be careful what you wish for. But it's a good point as well, in that it strikes me, someone listening to your talk might genuinely, especially you, might genuinely be confused, because if we are to think of one theory or the set of theories as in some filtration, you know, where they're getting finer and finer, right? You seem to be saying that they are the same. You seem to have like a functor, to go from one theory to the other.
Well,
and I think the notion is, I think, if I'm, and please correct me if I'm wrong, I'm probably wrong in some way, that you're mapping the structure of one theory to the structure of the other theory. That structurally, they are of the same type of theory. So you talk about a type of theory.
There is a way to look at the things, because in all the theories, we have states, we have processes, right? So process is going to be a map from states to states. And I need to have, the super class of states so that I can then have the classical states, the quantum states, and so on. But there can be stress on saying that these theories are different. I think has been sort of detrimental because there is a lot of structure that is the same. And there has to be a reason, right? And then the next iteration, if we want to go past, we need to understand what are the things that are common, that are still going to be there, and the things that have been different, why they're different. So the way that I relate classical mechanics and quantum mechanics, which is still on paper out right now, is that you can find classical mechanics as the high entropy limit of quantum mechanics. So you take quantum states, you go at high entropy, those are better and better approximated by classical states. But there might be a way to turn the thing around, so to take a classical theory and add some type of noise and get classical quantum mechanics on top of it.
Well, like stochastic quantization, for example.
Exactly. So at that point, you say, okay, what is the more fundamental theory? Because I can derive one by approximation, but I can also derive the other one by approximation. So it's just that in some conditions, you have some assumptions. In other conditions, you have other assumptions.
It's like a categorical view of physical theories in some sense, because you have like basically a natural transformation that goes from from to being, this between reality and theory, between a set of experiments and theory, and then you have a natural transformation between one theory and the other. I'm projection.
I don't think we have a transformation from theory to reality. I think you just have a common structure that they're all
Like a high-level thing that makes them.
Yeah, like you have topological spaces, groups, and then you have topological groups.
Right. So, and to link it with compassion, this is you in communicating and teaching. These types of analogies that are hidden, and usually they're avoided, right? And usually we describe each thing as different, as separate, and precise. The more precise we make it, the more different we want to bring out their differences. But perhaps it's useful that, in a sense, more compassionate, and a truer description of how the practitioners actually think about it. There's fuzzier things that, you look at the similarities, you're guided by principles of similarity and analogy, right? And I think just acknowledging that that's part of the sense-making mechanism and making it part of our practice in communicating. More broadly, I was saying in the previous discussion that we have as mathematicians, we have this very rare resource, right? We have access to the formative years of essentially everyone alive, we're very close to that. And the vast majority of them are left feeling like math isn't for them and there's nothing to enjoy in math. And be afraid of math, actually. So it's worse than just being indifferent, right? They're afraid of math. Like, it feels some sort of power to use against them. So it's got to change. Something has to change. This isn't working. And maybe just bringing in the more human aspects. How is it that we're doing it? Why is it that we're doing it? Humans have done it for so long, forever, right? Why? There must be something fun, some reason. Right? So let's program those passions that animate us, that make us choose and recognize mistakes and move on, and all of that stuff. What is that? That's part of mathematics. It's not experience.
So the part that I feel personally that is missing the most is this idea of mathematical modeling. So I learned a lot of things from abstract mathematics courses, right? And I'm doing multiplication, I didn't understand anything. And there was a class that was sort of the turning point. That was this guy that taught system theory. That at the second lesson, he stopped and says, guys, I know that all you guys learned what the curl or the eigenstates, and eigenfunction and eigenvalue and so on, you don't understand that. So he stopped and he told what those things were, like what they were going. And those are the things that I think are currently missing in a lot of the courses. I then repeat the thing on the undergraduate way with me. I basically said, okay, this is the geometrical representation, this is why you care about this.
Yeah, I have a question about the AI. So you were saying, people might go to generative AI, ask a question, and it'll say something wrong, and maybe give you an idea that'll lead you to the right direction. I feel like pushing back on that a little bit because, I could also go to my colleague or a colleague in a different department who could, I could discuss with them and they could give me something that's wrong or maybe not all the way there, but discussing with them in that same way could give me an answer. And maybe that's a little bit more pro-social, like maybe, what, in your view of where we go to AI to get towards right answers, should that make us like more disconnected from our colleagues?
So I'm not trying to advocate sort of one way or another. I think, we can sit at the computer and ask, open AI models. We can go and explore both of our colleagues. I think people are going to do both. Continue to do both. So I do think, again, insofar as we can get valuable insights, information from AI, it's a useful resource. But you absolutely, we need to decide how we're going to use it for the right way. Again, my goal was to raise the questions, not to recommend a particular answer.
Thank you.
A comment on that, the AI always responds when I try to reach out to people, and 90% of them don't get response.
Spencer, I want to bring you in on this because you're a computer scientist.
Actually, I should say I'm not a computer scientist.
Oh,
If
okay,
anything,
I'm
I'm a mathematician,
Okay,
but
okay.
I do some programming on
Quite a
the
bit,
side.
yeah.
But just another observation on that particular note is that the volume of questions on Stack Overflow has plummeted in the last 6 months, I believe. There's down to something like 300 a month. And a lot of that is down, at least the hypothesis is that a lot of that is down to the, down to the speed of response, right? So you post on Stack Overflow, maybe you'll get a response tomorrow. The AI, at least it comes back to you right away.
Does that mean that if I ask a question on Stack Overflow now, I have more of a chance of being responded?
It's hard to say probably because I suspect the readership has also declined substantially, but maybe not to the same degree. Hard to say.
Well, one thing that's skyrocketed is the number of nonsense submissions to journalists. So lots of people are now, writing these AI generated. There's just this tsunami of trouble.
Well, thank you all. Thank you very much for coming and speaking with us, and thank you for staying, guys. So come back in the afternoon at 1 o'clock. We'll have some lunch first. Thank you.